The Pythagorean theorem states that a squared plus b squared is equal to c squared. Now that's a bit confusing if you don't understand what that means. It's a rule that applies strictly to right triangles. That's not right. Which means the triangle has one 90-degree angle and two other angles that add up to 90 degrees. This looks like an isosceles right triangle, which means that these 2 degrees are 45, and that's a 90-degree angle. A corresponds to one length of the triangle, and B corresponds to the other length, while C corresponds all the time to the side length, otherwise known as the hypotenuse. A and B are interchangeable, so if you want, you could have this B, and this BA, or the exact same triangle, you could have this BB or this BA. Doesn't matter as long as this is always C. So we're saying that a squared plus b squared is equal to c squared. So if we're always told that in algebra you want to get it in simplest terms, so maybe you would want to say, well, why don't we just square root both sides? So a squared plus b squared equals c squared. Square rooted on both sides. Oh, surely this must mean that a plus b is equal to c. That's not true, because it wouldn't work because you're adding a and b. If you were multiplying a and b, then it would work. So if you had a times b, or ab, and you had this squared equals c squared, then yes, you could square root it and you would get ab equals c, because if it's a times b times a times b, that's a times b squared. And so if it's a times b squared, you could square root it and it will just be a and b. Because look at it this way. 3 squared is equal to 9, right? Think that's fair to say. 3 times 3 equals 9. So if 3 times 3 is equal to 3 squared, then square rooting it is essentially getting rid of one side, right? So if a times b, if ab squared equals c, then when you square root it, yeah, you'll get ab equals c. If it's a plus b, you can't, a squared plus b squared, you can't square root them individually. That wouldn't work out. So now you're saying, okay, that's all good, but I still don't understand why a squared plus b squared is equal to c squared. How is, I get that this is what we have to do to find c squared, or a or b or c if you're working algebraically, but why is that why it works? And so there's a way to prove the Pythagorean theorem. Imagine you have a square, but we're going to draw the square sideways, right? So let's draw the square. Now, it's not going to look like a square, but let's just assume it's a square for the time being, because I don't have a ruler. And now we're going to put this square inside of another square. Now what you'll notice when dealing with a square, now you can't really see it, dang it. There we go. Now let's tilt it. And now we draw another square that goes here to here, here to here, here to here, here to here. Okay, so now this is a square. Let's look at it this way. Okay, if we have a square side of another square, we know that it forms 4 right triangles. You have this one, this one, this one, and this one. And so let's find the area of this square. Now what we'll do is, if you notice, each right triangle is rotated 90 degrees. So for instance, the triangle over here looks like this, but the triangle up here looks like this. Same triangle, but it's been rotated 90 degrees. And so because it's been rotated 90 degrees, if this is A, we'll call this length A. So from this point to this point, that's A. Then from this point to this point is also A. From this point to this point is also A. Right? Oh wait, no, sorry, that's B. From this point to this point is also A. And from this point to this point is A. And the rest we'll call B. So we'll say that's a B, that's a B, that is a B, and that is a B. Okay? So, A and B are right here. We know that the entire area of the square is side squared, right? A equals side squared. The side of this big square is equal to A plus B. A plus B. A plus B is being squared to equal the area of the entire square, including this little square. That's the entire square. So let's call this big square area. If that makes sense, or the BSA. The BSA is equal to A plus B squared. How do we find the area of the center square? Well, what we could do is we could find the area of this triangle, multiply it by 4 because it's the same triangle all around, and subtract it from the area of the big square, the BSA. So what's the formula for an area of a triangle? The area of a triangle is 1/2 times the base times the height. the base is A, and the height is B, times 1/2. A is equal to 1/2 B. 1/2 AB. And that is for one triangle. If we want all 4 triangles, we have to multiply 1/2 AB times 4. 4 times 1/2 is equal to 4 divided by 2. 4 divided by 2 is equal to 2. So the area of all 4 triangles is equal to 2AB. So now we have to subtract. Let's make this a new sheet of paper, but we'll keep this on the side. Right? We have A plus B squared minus 2AB. Now, if you haven't learned foiling, then this might be a bit confusing. Or you could go to my video and to look up foiling if you want to know. But just know that when you foil, its FOIL stands for first. It's an acronym. It's not an actual thing. So it stands for first, outer, inner, last. And what that means is you multiply the first terms with, and you get that answer, and then you add them to the outer terms, the product of the outer terms, product of the inner terms, and product of the last terms. Basically, a rundown version. If you have A plus B squared, we want to FOIL that. So A plus B squared is A plus B times A plus B. It's not A squared plus B squared. No. Instead, it's you take the first, which is A, and you multiply them. So you get A squared. You take the outer ones. So A and B. You multiply those together. You get AB. So plus AB. You have the inner terms. You multiply those together. You get BA or AB, since multiplication is commutative, which means it doesn't matter the order. It's why 1 times 2 is the same as 2 times 1. So you also have AB. And then the last terms are B times B, or B squared. So you do have A squared plus B squared, but you also have AB plus AB. And when they come all together, you get 2AB plus B squared plus A squared. Now you might see where this is going. If you have A squared plus 2AB plus B squared, and then you have to subtract that, you have to subtract 2AB from that. 2AB minus 2AB gives you 0, so it's A squared plus B squared. A squared plus B squared is equal to the area of this square. Now, what did we always say about triangles, or right triangles? We said that this side will always be C. If this side is always C, and you have that exact triangle right here, we know that this is C. So you're saying, oh, well, what was the point? You could have just said it was C squared. And that's the point. If this is C, then this side times the smaller circle's area is C squared. All the algebra that we just did proves that A squared plus B squared is equal to C squared. And this is why the Pythagorean theorem is true, and exists. If you didn't understand the part about the foiling and the algebra, then you don't really have to pay attention to that. That's not the true purpose of the Pythagorean theorem. It's just a way to help explain the Pythagorean theorem and why it works the way it works. What you have to know is A squared plus B squared is C squared, and that means that the side of the triangle is equal, the side of the triangle squared is equal to the base of the triangle squared plus the height of the triangle squared. Why then, so you're probably wondering why it's not B squared plus H squared is equal to S for side length squared. Why? Because that doesn't look as pretty and isn't as memorable as A squared plus B squared is equal to C squared. ABCs is more memorable than BHS. BHS just sounds like VHS. And we don't want to mix up VHS with BHS. And that's why it's A squared plus B squared is equal to C squared. And all the algebra we just did is why A squared plus B squared equals C squared. Thank you and good night.